Okay, so in this video, we're going to be going over the mean, median, and standard deviation, and also the range in AP statistics and how to calculate them. So, starting off with the mean. First of all, what is the mean? Well, the mean, also known as this variable of x, is equal to the sum of all the data divided by the amount of data we have in that specific distribution. And what the mean is basically the average number in the data. So it's like the average height is 5'9", the average yada yada. That's basically what this is talking about. So let's see exactly how we can use the mean for calculations. Okay, say we have 20 games that we're looking at, and I'm actually going to type this out. So let's say we have 20 games, and these are all the goals scored in each of these 20 games. Now we're being asked to calculate the mean in this problem. And basically the way to do that is, if you recall the formula we had just done, the formula we had just gone over. By the way, this symbol basically means like the sum of all values that comes after that symbol, just so we're clear on that. So the sum of x, each x value divided by n. Well, we know that n equals 20 because we have 20 games total, so we get the 20 here. But now we have to find the sum of all the values. So we add all these values together, and when you do that, you get 63. Then you have to divide 63 by 20, and you would end up with a mean or average of 3.15 goals in all 20 of these games. And that is how you calculate the mean with distributions. Now let's talk about the median. And before we get into delving too much into the median, I want to show you guys the difference between the mean and the median, or not really the difference, but the relationship between the two in certain situations. So let's say we have graph 1. We have this distribution. Then let's say in graph 2, we have this distribution, which is like a bell curve. Then in graph 3, we have this distribution. Now, hold on. Okay, now, looking at the first distribution, we know that our median is going to be somewhere like around here. The median, by the way, is like the number that is like smack in the middle of the distribution when you put them together. So like, say you have 1, 2, 3, 4, 5. 3 is your median because it's in the middle of that data. Whereas the mean is like you add 1, 2, 3, 4, and 5 together, and that would get you 15. Then you divide it by 5, which is the amount of numbers in that distribution, and you get 3 as your average. And in this case, say the mean is like right here. In this case, the mean is greater than the median. So when the data is skewed to the right, the mean is greater than the median. Now in case number 2, our mean and median is going to be on this line, like smack in the middle. Here our mean would just simply be equal to the median. And in case number 3, because we're skewed to the left, our median would be probably around there, and our mean would be probably around here. So our median would be greater than the mean. That's basically the relationship between the mean and median in certain distributions, specifically in these type of distributions. Now let's actually figure out how to use the mean. That means the median. Okay. So let's say, whoops, that's not supposed to show up. Let's say we have this data. Okay, let's say we had this data. We have all these numbers and we're trying to figure out the median. Okay, all you have to do here is just find out the number that is smack in the middle of this distribution. So let's just go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. 1, 2, 3, 4. And you end up with both of these twos. Now, what do you do when you have two median numbers? This happens when you have an even amount of data in your data set. So what you're gonna have to do to calculate the median is to add these two numbers, so 2 plus 2, and divide it by 2. In that case, you're still left with 2. So that would be your median. And this is actually the same distribution we had for our mean to calculate our mean. So our mean is still going to equal 3.15. So what does this mean? Well, this means that 2 is in the middle of our distribution, whereas 3.15 is pretty much the average amount of goals in our data set. That's basically the difference between the two. Now let's go ahead and talk about, well, I'm going to briefly talk about the range, which is actually a pretty simple concept. So let's say we have 1, 2, 3, 4, and 5. Our range is simply equal to our max minus min value. So we're going to take our maximum value 5 and minus it by our minimum value 1 and get 4. That's our range. All right. So moving on to our standard deviation. I'm not going to delve too deep into our topic regarding range because we don't really have to. It's a pretty simple concept to understand. Um, S of x represents the standard deviation, and this is equal to the square root of the sum of all x values of each x value minus the mean squared divided by n minus 1. This is our formula to calculate for the standard deviation. Okay, so let's use an actual question to implement this formula. Okay, let me go ahead and type this in. So let's say we have this distribution, this piece of data. We have 1 1, 2, 3 2s, 4 3s, 2 4s, and 1 6. Now we want to know what the standard deviation is. Well, to figure out the standard deviation, if we refer back to our formula, we need to know a few things. We need to know x of I, which is pretty much all these values, each and every one of these values, so we don't really have to do anything there. So for now, we could just put a check mark. We already know what x of I is because we already have it. Now we need the mean, which we don't have. So let's put a red question mark there because we need to figure out that as per the formula. And we need n, which we're already given to in this data set. So we have that. In this particular data set, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So n equals 11 to put in retrospect. So we just need to find out what the mean is. And we already know how to calculate the mean, right? The sum of all the values divided by n. So if you put this in the calculator, you would get 33. And your mean is going to end up being 3. So that's your mean. Let's go ahead and write that down actually. Our mean is 3, just so we don't forget. Now we have all the variables we have to figure out what the standard deviation is. So let's do this. Okay, so there's just one complicated concept in this formula, in the standard deviation formula, and that's this. So what this is basically saying is that for each value in this data set, we have to plug that into x of I, minus it by the mean, square that, and then save that value. And then once we're done calculating all these values, we add them together, and that's what this little symbol is for. So let me go ahead and demonstrate what that means. So let's say for 1, we have 1 minus 3. Whoops, that's a bad looking 3. I'm not using my pen right now. My pen is dead. So I'm using my finger. So 1 minus 3, negative 2 squared, which is just 4. So we have 4. And then 2 minus 3 squared is just 1. We have 3 2s, so we can just infer that we're going to have 3. Because since we have 3 2s, we're just going to end up with 3 1s, and we could just add those ones together to make it more simple. And then 3 minus 3 squared, which is just 0, so we don't have to really write anything for that. Then we have 4 minus 3 squared, which is 1. So since there's 2 4s, there's going to be 2 more 1s, so we could just put 5 here. And then 6 minus 3 squared is going to be 9. So now you do 4 plus 5 plus 9, you end up with 18. Wait. Yeah. You end up with 18. And now we've calculated that part. So now all we have to do, divide 18 by n minus 1, which is 10. And you get 1.8. You square root that, and you should end up with, if I'm not mistaken, it should be 1.34. Yeah, 1.34. So your standard deviation is 1.34. Now, what does this mean conceptually? So let's get rid of all this data and everything else we have here. Okay, so hold on. So what this means is that it really means two things, but let's say that we know that the mean is 3, right? Now, since the standard deviation is 1.34, if say a value is 1.34 plus 3, if it's greater than 3 by like say 1.34, which is the standard deviation, then that means it's one standard deviation greater than 3, right? Because that's one standard deviation. Whereas on the other hand, if a value is 1.34 less than 3, then it's whoops, it's a bad looking S. Then it's one standard deviation less than 3. So that's basically what it means conceptually. So that's how means, medians, ranges, and standard deviations work in statistics. Next video, we're going to be going over inner quartile ranges, quartile 3, and quartile 1. And then after that, we'll get into z-score. All right. Besides that, that's all I wanted to say in this video, and I'll see you guys in the next one.